Hi, hello and Assalamualaikum. In today's video, our group will be present about one of application of differentiation, which is related rates. Now, let's meet our amazing group members. Let's start from Nurul Aisyah Khadeeja, Noor ARISHA SOFEA, ABDUL QUDDUS, and the last one, ABDULLAH ALIM. All of us are from CS112 Class F. So, let's begin.
So, what is differentiation? Differentiation is a process of finding derivative or rate of change of a function. Why we use differentiation? We use differentiation to determine the maximum and minimum values of particular functions. To solve differentiation problem, there are three techniques that we can apply, which is derivative of sum difference, derivative of a product functions that called the product rule, and lastly, derivative of rational function, which is the quotient rule. The rate of function is defined as dy dx, fx, and y. There are 5 applications of differentiation that we had learned, which is related rates, analysis of function 1 that conclude increase, decrease, and concavity, analysis of function 2 that conclude relative extrema, first derivative test and second derivative test, maximum and minimum problems, and also Rolle's theorem and mean value theorem. Now, for this task, I will explain about related rates. Related rates is a problem that involves two or more variables that change at the same time, possibly at the different rates. In a simple way, related rates is a problem that involves at least two changing quantities and the rate of change usually with respect to time. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure of this application is to find an equation that relates to quantities and use the chain rule method or the often used method, which is implicit differentiation.
For the problem statement, the designer of a box company wants to produce an open box from a piece of card with the width of 14 cm and the length of 20 cm. The box is made by cutting out squares of length x at each corners. The sides of paper are folded up to form the box as shown in figure 3.21. For the question 1, show that the volume of the box is V equal to 4x power of 3 minus 68x power of 2 plus 280x. For question 2, find the value of x so that the volume of the box is maximum. For question 3, find the dimensions of the box so that the volume of the box is maximum. And the last question is, find the maximum volume of the box.
For question 1 Roman, show that the volume of the box is V equals to 4x cubed minus 68x squared plus 280x. So, step 1, after we cut off the surface, we will get the new equation for width and length while the height remain the same. The new equation for width and length will be 14 minus 2x cm and 20 minus 2x cm respectively. Then, we will substitute into the formula of volume of the box and we will get V equals to x times 20 minus 2x times 14 minus 2x. After we substitute the formula, we can expand the bracket and simplify the equation. The answer will be 4x cubed minus 68x squared plus 280x. Now, it is proven.
Next, for the second question, we need to find the value of x so that the volume of the box is maximum. In order to find the x value, we can use the first derivative test on the volume function. Firstly, we need to let dv over dx is equal to 0. Then we have to differentiate the volume of the box to get 12x squared minus 136x plus 280 is equal to 0. Then from the equation that we just differentiate, use the root of quadratic formula to get the values of x. We'll get two values of x, which are 8.629 and 2.704. After that, To test the values of x that give maximum volume of the box, we can use the second derivative test. From the equation that we just differentiate earlier, we have to differentiate it again to get d square v over dx square. Then insert the values of x that we got into d square v over dx square to define which value of x can give the maximum volume of the box. Therefore, we can conclude that the value 2.704 is the x value which can give the maximum volume of the box because it gives negative value when we use the second derivative test.
For question 3 Roman, find the dimensions of the box so that the volume of the box is maximum. For this question, we need to do the measurement of the box using x equals to 2.704. For length, just substitute the x into the formula length equals to 20 minus 2x and the answer for length is 14.592 cm. Next, we substitute x into the width formula 14 minus 2x and we will get 8.592 cm for width. Last, we substitute the x into the formula of height equals to x and we will get 2.704. So, let's move on to the next question.
For the question 4, we find that the value of x is equal to 2.704. Then, we'll just need to insert the value of x into the volume formula of the box. From that, the equation will be 4 bracket 2.704 power of 3 minus 68 bracket 2.704 to power of 2 plus 280 bracket 2.704 and then we'll get the answer that is 339.0126 cm cube.
By applying differentiation method into this problem, we can conclude that the application of differentiation can be used to define a value of volume. Not only that, differentiation method can also be used to solve any other kind of problems. Hence, another time in our life, differentiation method is very effective to solve problems related to value of a volume.
We are really grateful because we managed to complete this video presentation within the time given by our lecturer, Madam Rashida. This assignment is impossible to be done without the amazing cooperation and effort from our group members, Aisyah, ARISHA, Haq and QUDDUS. We also sincerely thank our lecturer of Calculus 1, Madam Rashida, for the guidance and willingness to help us in what we are lacking when completing this assignment and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all this time. That's all from us. Thank you for watching.